All right, what up, AP Pre-Calculus students? Here's your second homework video. Remember, we are using this to check. We're not using this to just copy down without putting any thought into it. We're moving on from a isolated x to quadratics, where you can't isolate x. So the strategy we need to take is to turn things from a sum, whether it's any version of this, where we have it set equal to 0 into a product, some sort of product set equal to 0. The reason why we do this is because we understand the zero product property, which says if you're multiplying anything by 0, it's 0. Or conversely, if you got a 0 in any piece of a product, you get 0. So it's an advantageous property because if you can turn a sum into a product, boom, you can just take your individual pieces and isolate your x's if there's an isolated x in there. So some things of some what we have to do is kind of like undo distribute. We understand distribution turns into sums. To undistribute, we need to like unmultiply. We almost like need to divide. We need to what is called factor. Okay, so factoring is the key that turns sums into products. And there's techniques to factor, techniques to undo distribution. First is undoing a greatest common factor. Like the easiest distribution is having something times something else like that. And we have just one thing that is multiplying into two things, giving us something like that. We want to back that out by dividing out essentially that term that is multiplied in. This is like confusing to some, but it's like, hey, what is multiplied into both of these? What do both of these share? An x must have been multiplied in. So I'm going to factor out an x. Some techniques you might have seen in your Algebra 2 classes is using a box, understanding that x times x is x squared, x times -6 is -6x. You can rewrite x squared minus 6x is x times x minus 6. Then we have a product equal to 0. When do each individual piece equal 0? We could split this up into two separate equations. This is unnecessary to do. You could just look and see x could be 0 or x could be 6, but just showing you what we're doing here, step by step. Same thing here. Both of these terms share an x, so I could divide out or undistribute or factor an x out. And when I do that again, we have a product, two things, which could equal 0, and when they equal 0, the entire left side will equal 0. So the solutions are -9 and 0. If I plugged in 0, I get 0. If I plugged in -9, I get 0. Ooh, that's gross. I gotta fix that. There we go. Okay. I want to kind of zoom in a little bit, but whenever I zoom in, it goes crazy. It goes all wonky. I think I need to change that. Oh, there we go. All right. What do both of these terms share? What is multiplied into both of these terms? Well, a -4x times x gives me -4x squared. A -4x times +4 gives me -16x squared. Again, you could use the box method if you want to, but we're kind of trying to get you guys to go beyond it, just to kind of think about what's happening versus memorizing techniques. It's like this equals that. Both of these terms have a shared thing that is multiplied in, this -4x. You could also do +4x, it's fine. But again, we'll get x equals 0 from this one, and x equals, I'm going to skip the step and just do -4. That is the solution, that is the root, that is the 0. 9x and 3x squared, a 3x is shared. 3x times 3x is 9x squared. It's 3x times 3. And then minus an x. So I get here, x is 0. And here, 3 minus 3 is 0. Okay? You notice that all of these, we have 0 on the other side. You will see later in the homeworks, you will not have things equal to 0. And this is when we need to understand that you can't isolate x. So when you can't isolate x, we got to have something set equal to 0 and try to factor. So move everything onto one side. All right, cool. Same thing, find the zeros of f. So that's when f of x, the function, the machine produces a 0. We just kind of worked through these. No big deal. A greatest common factor. You can write it like this. You could write it like this. Find f of -3. So this is kind of like back to day one, just doing the stuff that we did. Practicing getting outputs, getting y values based on x values. You can make this plus a negative. Don't distribute the negative to both. You could do that, or you could just subtract -24, make it a positive 24, add a positive. Just don't make mistakes. All right, here we go. Solve the equation f of x equals 9. So when does f of x produce an x value of 9? Now, here we go. If you factor this, there's no advantage to having a factored thing set equal to a number, because all you'd have to do is start guessing and checking, and that's not helpful. We don't factor set equal to numbers. There's no advantage to doing that. The advantage comes from factoring set equal to 0 because of that 0 product property that we talked about. Now, a lot of you, for this is an x squared plus bx plus c, like to use an x. I don't like using the x because sometimes it can confuse students. I just understand distribution. If I have x plus a times x plus b, if I understand distribution, I'm going to use numbers. I understand we get an x squared, we'll get a 4x, we'll get a 3x, and we'll get 12. Because I understand distribution, I understand that the two numbers, well, first, since I understand distribution, I understand that this x squared plus bx plus c can look like a product of two binomials. That's the first thing I know. I know that x plus a times x plus b turns into an x squared plus a number x plus a number. First thing. Second thing I realize is that my two numbers in the binomial, this 3 and this 4, add to get the middle term because we get the 3x plus the 4x. They multiply to get the last term because you get the 3 times 4. So what I do whenever I see x squared minus 8x minus 9 is I know it's going to be x plus something times x plus something. I just start out like that. And then I think, I don't use the x. I just say, what are the two numbers that go here and here that add to get the -8 and multiply to get the -9? Okay? This is what I do. If you want to keep using the x, that's fine. It's just, depending on which numbers you put where, you might make a mistake and you might not really understand what you're doing. So, -9 and 1 add to get -8 and multiply to get -9. Now that we have the factor form, again, when this piece equals 0, that's when x is positive 9, the whole thing will 0. When x is -1, when this piece equals 0, we get the other solution, the other 0. All right, f of x equals -16. So again, x squared minus 8x equals -16. It is not advantageous to add factored equal to a number. That does not help you at all. having equations set equal to 0, always advantageous. You can't isolate the x because you have two different versions of x. You have an x squared and an amount of x's. But we do know an x squared plus a bx plus a c can look like x plus a number times x plus a number. If you can find those numbers, hooray. If you can't find those numbers, we'll talk about the next thing we could try next class. But we can. The two numbers that add to get -8 and multiply to get 16 are -4 and -4. So I found those two numbers. I understand that if I distributed this, I would get this. I get my answer 4 twice. Now, you're not going to list off 4 twice, but we will talk about in the future how 4 occurs twice, or it has some sort of multiplicity. But don't worry about that. It's just 4 is the only answer. Okay. We will start getting into, once we get to E and F, factoring things where A is not 1. Once we get there, we'll talk about it. For right now, let's just stick with the easy ones. When we have 1x squared, that means you have to have x times x to get x squared. Two numbers that add to get -5 and multiply to get 6. So multiply to get +6, add to get -5 is -3 and -2. If you listed off these numbers in the wrong order, you might get, you might factor incorrectly if you use the x. So just make sure you don't make that mistake. Here, x could be 2 and x could be 3. That would be able to make this whole thing 0. It will be advantageous to move everything onto one side. Understand that a trinomial like this could start out like this. Find the two values that add to get 7 and multiply to get 10. 5 and 2 means the solutions are -5 and -2. Pause, hold on, wait. This actually is something that we can see all three terms share, like something that was multiplied in. It shares a factor. 2 is a part of all three of those terms. Before we try to turn it into something like this, we instead say, oh, hey, let's divide out or factor out the 2 from all of the terms. Now, what's important here is that this 2 stays there. Cool. The two numbers that add to get +3 and multiply to get -4 are +4 and -1. Now, what are the values for x that make this 0? Well, we can tell from this one, -4. We can tell from this one, 1. Too many students assume that since you have this guy on the outside, that makes 0 a solution, or that makes 2 a solution. That's not true. Think about it. If you plugged in 0, it has to be plugged into x, the variable. You'd have 2 times 4 times -1. That's not 0. If you plugged in the value 2, you'd have 2, because I can't change this number, it's just the number, times 6 times 1. That's not 0. So just because we have this number 2 on the outside does not mean we have an additional solution. My only 2 solutions are this -4 and this 1. Let's go to D. Again, it's not advantageous to factor until we have something set equal to 0. So I'm going to move the 12 onto the right side, onto the left side. I will factor out a greatest common factor. All of these terms share a 4. Now, the 4 is going to stay here, but this trinomial, this x squared plus amount of x's plus a number, can factor to be x plus one number times x plus another number. All I have to do is find the two numbers that add to get +2 and multiply to get -3. It's got to be +3 and -1. Just because 4 is here does not mean there's an additional solution. 0 is not a solution. -3 is. +1 is. You plug in any other value, you won't get 0 on the left term. All right. Coming to E, F, G, and H. There's a lot of ways to factor E, F, G, and H. This is when A does not equal 1. And it's actually one of the most complicated things to teach with reasoning behind it. Like, I could tell you the reasoning behind why we want to do this, but it's actually complicated to understand, okay? Now, what you guys have learned in the past, depending on your teacher, is the following. Multiply A by C, okay? This reveals a crucial number to help us find and undo the distribution of two things. Now, I'm going to tell you right now, if you understand distribution, you know what goes here and you know what goes here, okay? This has to be 2x and this has to be x, okay? But let's just take a break. Let's go with the technique that you guys have learned because it does work. To reveal the numbers that are important, we will multiply A by C, get 30. We'll leave this B as -11. We're going to find two numbers that multiply to get 30 and add to get -11. Okay, so we're still working with this add of -11, but now we're talking about the multiplication of 2 and 15. All right, the two numbers are 6 and 5, -6 and -5. Now, here are the two techniques. And then I'm going to show you a third technique. If you had Miss Losky, Miss Johnson, if you had myself in on-level algebra 2, if you were on level algebra 2, this is what you did. You found these two numbers in the x. Okay, so you did like 30 and -11, and you found the two numbers. Then, instead of going straight to the factored form like this, you created a box. Because you understand that multiplying is like finding area. So if like you multiply x plus 2 and x plus 3, you can like fill in this area of this box and add them together, and you can see you'd get that 5x plus 6. But what we're doing is kind of including this middle step, which is showing the middle step when you're distributing. It's like showing the step here of having the 4x and the 3x. We skip it when A is 1, but we need to include it here if you want to. And again, this is one technique you can do. Now, the key is understanding, well, things multiplied to fill in this box. Like, there's stuff that multiplies together to fill in the box. And you can kind of look at 2 at a time to figure out what must have come from this. Like 2x squared and 5x, they share an x. So I'm going to put an x right here. Now, what's great about this technique is that once you fill out one box, you could start to fill out the other boxes just by kind of thinking about multiplication. Like if this is x, 2x times x is 2x squared. -3 times 2x is -6x. -5 times x is -5x. And -5 times -3 is +15. I just kind of undid distribution using this technique. Getting 2x minus 5 and x minus 3 must have been my binomials. Okay, that's one way to get it. If you had Mr. Huffaker, or if you had Miss Salas is going to teach this. They're going to teach you to rewrite, have this like middle step of the distributed thing like this, and they're going to teach you to factor by grouping like that, and you're going to have a 2x and an x minus 3. You could factor out a +5, but then you'd have -x plus 3. You don't want that because you want to be able to factor out a shared term, so this is how we get a -5 and x minus 3. And then boom, you factor out the x minus 3 and you got 2x minus 5. This is a technique that has been shown in a lot of past math classes. Or I'm not going to use that. I will use the X box just because I actually do think it's nice. But what I'm going to do mostly is understand that if we have like a prime number here, you know this has to be 2x and this has to be x. I got to just kind of guess and check so that I can get positive 15 and negative 11. This is how I actually was taught how to factor. It's like, well, can I make negative 11 if I use 15 and 1? It's like, no, 15 and then 2 can't give me 11. So then it's like, all right, well, the other options are 5 and 3, either here, 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 and here. And it's like, okay, well, if this is a 5 and this is a 3, this will be 6 x's. This will be 5 x's. That's good. If I make it a negative, I'll have negative 5 x's, negative 6. Like guessing and checking used to be the way that people factor. Okay. If you want to go ahead and guess and check, great. If you want to use the Xbox, I'll show you that from now on. Now, we have to find the solutions. So once we get here, you have to figure out what x makes this 0. Maybe you're not comfortable getting right to the answer, so you can go ahead and solve. Add 5, divide by 2. You should, guys, you have to do this yourself. If you are just copying this down, you're not helping yourself out. Okay? So if you just copy down E, try to do F by yourself. Okay? If you're copying down E and F, try to do G by yourself. Try to do H by yourself. All right, I'm going to do the Xbox method, or the two numbers that multiply to get negative 24 and add to get negative 5. The two numbers are 8 and 3. Negative 8, positive 3. I'm going to break out the box. I actually like this method. And I want to look out for my on-level algebra 2 students. If you don't like this method, if you're like, I hate doing this stuff, and it doesn't make sense, like, why do we multiply A and C? It's just like, it's just the way to discover and undo the factors. If you want to, go ahead and test yourself. Try to guess and check. You know, since you have 2x squared, and we're only going to give you prime numbers here, you know you're going to have 2x and x here. Try to guess and check. Figure it out. All right, while you're figuring it out, I'm going to do the Xbox method, where I have negative 8x's and positive 3x's. I'm kind of undoing the distribution, and then I'm just going to undo the multiplication. X times 2x is 2x squared. 2x times negative 4 is negative 8x. X times 3 is 3x. Negative 4 times 3 is negative 12. It's got to be x minus 4 and 2x plus 3. If you figured that out, great. You could just kind of guess and check and work with that. I'm going to show you guess and check on the next one, just to see if I'm still good at it. We got to figure out when 2x plus 3 equals 0. Subtract 3, divide by 2. X is equal to negative 3 halves. We got to solve that, so x equals 4. Those are my two zeros, my two solutions. All right, let me show you G by guessing and checking. You got to add 13x, you got to subtract 2. I know we have to have 7x and we have to have x to get 7x squared. There's no other combinations. I know I got to have a 2 and a 1 to have negative 2. Now I know that to get 13x, I'm going to need like 14 x's somewhere. So I'm going to go ahead and make that a positive 2. And I'm going to go ahead and make that a negative 1. Why? Because I know it's going to be 14 x's and negative 1x. This is an easy one to guess and check. This took probably less time than the Xbox method. If you did the Xbox method, you're going to get 7x minus 1 and x plus 2. Go ahead and try it. Okay? Find the two values that multiply to get negative 14 and add to get 13. Fill in your box. Undo the distribution. From here, we're going to add 1, divide by 7. You get x equals 1, 7. From here, you're going to get x equals negative 2. All right, I'm going to try to guess and check on this one, but I'll also show the Xbox. This one I think is going to be harder because it's 15, which means you have options. You could have 15 and 1, or you could have 5 and 3. I'm assuming it's going to be 5 and 3, so that's what I'm going to go with. Okay, 5x minus 22x plus 15, minus 15. We're subtracting the 22x, we're subtracting the 15, put it all on one side. Okay. I know it's got to be 5x and x. I got to get 22. So if I did a 3 here, I'd only get 15, and a 5 here, I'd only get up to 20, combining 15 and 5. If I put a 5 here, I'd get 25, and a 3 here, 25 minus 3 could be 22. So if I get a minus 5, I'd get negative 25. A plus 3, I'd get negative 22 after combining things. Okay, so that's guessing and checking. Let's say you didn't do that. Well, you got to do 15 times 5. That's fun. You get 75. I'll make a video. Okay, say hello to Precalc students.
Hi, Precalc. I have a question for you.
Yeah.
Can you run me a pass?
No, I'm not doing that.
You're not?
No.
All right, I guess.
Cool.
Hi, Precalc.
The two numbers that multiply to get 75 and add to get 22, it's going to be negative 75, or negative 25 and positive 3. So in the box, tiny box, I'm sorry about that, but I got 5x squared, I got negative 25 x's, I got positive 3 x's, and minus 15. This has to be a 5x because it shares a 5x and a 25x. This has to be x, 5x times negative 5, x times 3. There you go, 5x plus 3x minus 5. Got the same thing. Solutions, negative 3/5 and 5. If you didn't know how to get negative 3/5 and 5 like that, just show your work. 5x plus 3 equals 0, x minus 5 equals 0. All right, different types of questions, but really all the same. G of x can be written as ax squared plus bx plus c. Find the values of a, b, and c. They just want you to distribute. Okay, so a is 4, b is 20, c is 0. There's no c, it's plus 0. Find the y-intercepts of the graph. The y-intercepts are when x is 0. Finding the y when x is 0. Find the y when x is 0. So g of 0. 4 times 0 times 0 plus 5. All right, that's 0. So the y-intercept is 0. Find the x-intercepts. That's when we're trying to find the x when y is 0. So this is when we are finding the zeros of the function or the roots. Here it's already in factored form. Fantastic. Here, 0 could be a solution because 0 can be plugged in for x, 0 times 5. And here, negative 5 is a solution. Sorry if you can't see that because of my face down here. Find g of negative 2. It's probably advantageous to keep it in factored form. I get negative 8. Make sure we work order of operations here. I'm going to go inside the parentheses first. Get negative 24. Solve the equation g of x equals 24. Now this is a good one. So let's say I had 4x times x plus 5 equals 24. It is not advantageous to have a factored form set equal to a number. This gives you no help at all. You could try to guess and check. Maybe you'd figure it out. But it's actually better if we had this distributed with the 24 on that side, have things set equal to 0. Oh, look, all of these terms share a factor of 4. 4 must have been multiplied in to get this. Factor out or divide out or undistribute the 4. Get this. Two numbers that add. I do not have to do the x box. I don't have to do the box because it's just a 1. I know it's going to be x plus a number times x plus a number. I have a 4 in front though. The two numbers that add to get 5 and multiply to get negative 6 are negative 6 and positive 1. Now, the 4 is just a constant. It does not add another 0 because it's not 4x. If it was 4x, then yes, I could plug in 0 into 4x, but it's just 4. I can't plug in and change that value. So the only two solutions I have are 6 and -1. Okay? The solutions are the values you can plug in for x. There's nothing that you can change about just 4. 4 is 4, it's not 4x. Cool. Rewrite it as this. Yo, you got to remember how to multiply t minus 3 by t minus 3. We changed it to t's. Oh no. But like, remember understanding distribution, you're going to have t squared. You're going to have -3t, -3t, and then +9. If you want to write that out one step at a time, great. But we kind of talked about in class, you should understand like the shortcut. If you understand how to factor, you should understand how to distribute quickly without doing like the box method. You should understand like, oh, I'm going to have a t squared. -3 plus -3 is -6. And then -3 times -3 is +9. I kind of showed you both. Good. And then we got a -2t. So I'm going to combine the -6t and the -2t so that I can get the a t squared plus bt plus c. Cool? Solve the equation h of t equals 18. It does not help me to have this equation equal to 18 because of I'm not able to isolate t, get t by itself. So the only thing I would probably want to do here is start out with the simplified or the undistributed form. No. Start out with the distributed form, the standard form. Set this equal to 18. Move everything onto one side. Subtract 18, I get -9. Factor to solve. I know this is going to take the form of t plus a number times t plus another number. All I got to do is find the two numbers that add to get here, multiply to get here. I'm skipping the box because it's just a silly, unnecessary thing to do. You get -9 and +1, giving me the solutions +9 and -1. Ooh, k is t squared plus 5. What makes h of t equals k of t? So here we are taking h of t. I'm going to go ahead and use the distributed form of h of t and set that equal to k of t because I can see right away that I can subtract t squared and it's gone. I'm just getting -8t plus 9 equals 5. This is an equation I can solve. Don't make the mistake of saying this is 2. Come on. I have so many students that are like, oh, divide by 4. No. What is bothering your variable? What can we need to undo the program. Undo the program. Undo what is being done to t. Divide by -8. You get +1/2. All right. Almost there. We got a triangle. How many values of x make the perimeter equal to 12? So it's a triangle, 3 length sides. Perimeters, we'd add them together, so no big deal. When does that equal 12? Like terms, 6x squared, 6x. Does not help to factor this equal to 12. It will help to have everything on one side equal to 0. We do have a common factor that can be divided out, undistributed. 6 can be distributed in. I just pulled it out, I factored it out. Two values that add and multiply because this can look like x plus a number times x plus a number. Two numbers are positive 2 and negative 1. This does not give me a solution. There's no value I can plug in to 6. It's just 6. It's not 6x. Don't make that mistake. Too many people do. Those are my solutions. All right, here we go. These are great questions. These two questions, I think you're going to see a lot on your test, on your quiz. Yo, you got to be able to do these. I'm just going to say, yo, quiz/test. You know why we love these questions? Because you have an amount of x's here, you have x's here, you are not able to isolate x. You can't add 2x and then square root both sides. It's not going to help you because you don't know what 9 plus 2x square rooted is. You can't simplify it to be 3 plus like root 2x. That doesn't work. You're not allowed to do that. So the reason why these are such great questions is because it forces you to both distribute, then simplify, then factor. You have to multiply x minus 3 by x minus 3. You have to get x squared minus 6x plus 9. Then combine that with the negative 2x. Move the 9 over. That is so, I'm sorry for being so messy, but I hope you understand. I just distributed. I still have the negative 2x. I have the 9. I just combined the negative 6x and the negative 2x. I will subtract the 9. That's gone. I get 8 x squared minus 8x equals 0. I can factor out an x. Since I have an x factored out, I have solutions 0 and 8. You can plug in 0 into x. You can't plug in 0 into 6. Got it? This one, great question. You got to be able to do this. Try this by yourself. Don't copy this down. Start by distributing. Yo, x plus 2 times x minus 5. If you want to do it one step at a time, fine. X squared, negative 5x, 2x, negative 10. But maybe you know, because you know how to factor, just like 2x's, negative 5x's, I'm going to have negative 3x's. I'm going to have negative 10. I also have negative 18. Doesn't help to have that 18 on the right side. Keep it here. Instead, just combine the negative 10 and the negative 18 to get negative 28. Find the two numbers that add to get negative 3 and multiply to get negative 28 to now undistribute to factor. Negative 8, positive 5, giving me solutions. Wait, what am I thinking? It's got to be 7 and 4, right? 7 times 4 is 28. Wow, it's like it's been a while since I multiplied 7 and 4 together. And I'm like second guessing myself. Why did I say 8 and 5? I don't know. All right, negative 7, positive 4. 7 times 4 is 28. 7 times 5 is 35. 7 times 3 is 21. Summer break, man. Summer break gets to all of us. Summer vacation gets to even math teachers, okay? Even math teachers are rusty. All right, x-intercepts is when y is 0. When does the function produce a 0? That's easy. That's negative 4 and 5. You can't plug in 0 into negative 3. It's not negative 3x. It's just negative 3. Don't put 0 there. Y-intercept, x is 0. So like y of 0. Plugging in 0 for x. Negative 3 times 4 times negative 5. So that's negative 20 times negative 3 is positive 60. Cool. Write the function in an equivalent form that displays the zeros of the function as a constant or coefficients in the expression. This is a long way to say, yo, if I asked you to solve this equation or like find the zeros, what would you do? It's a long way to say like, what's an equivalent form that displays the zeros? You're going to see this actually on your test, this very type of question. And what you're going to be asked to do is you're going to be multiplying everything together. You're going to be simplifying, and then you're going to factor. And this is the equivalent form that displays the zeros. X minus 5, x plus 2, or x plus negative 5, x plus 2. This displays the zeros of the function. This displays the solutions to f of x equals 0. Okay? We are essentially taking like 2 days from Algebra 2, and we're smushing it into one. We are reviewing this stuff, but we're also reteaching you this stuff. So, if you're having any struggles, you just got to keep practicing, okay? If you copied down answers, go back and redo the problem yourself, okay? Go back and redo the problem yourself, or else you're going to get to the quiz and you won't truly know how to do the certain problems, okay? You got to struggle. You got to figure it out yourself. The quicker you do that now, the easier this class is going to be in the long run. You got it? Mr. Messer's out.